Hey, folks. What I want to do now is talk to you about a few utilities that you can use in Linux that relate to the domain name system, and talk about the domain name system in general. There's quite a few things that we need to understand before we get to the point where we can really use and understand all of the infrastructure that DNS is built on. But there are a couple of few simple ideas that I think are important to throw out there early in a networks course, and so that's what we're going to do. So every device on a network has to be identified by some address, and this is a multi-layered, multi-tiered problem. But the one that we're going to focus on is really at the much higher application level layer that we kind of think about. So at that layer, every machine has an IP address or an internet protocol address, and the problem becomes that remembering all of those addresses is complicated, and it's much less likely for something to be able to be viral or marketed in that sort of environment. And so we tend to name the machines instead. So you already know those naming schemes, google.com, or you can see on the screen wikipedia.org. Those are names, and those certainly aren't addresses. And so we need a system that translates names into addresses so that when you type google.com into your browser, we go to the proper machine that's actually going to serve google.com. In this case, that situation is way more complicated for Google. It's not just one machine, it's a whole host of machines. But we're going to try to keep things simple in this brief first discussion. So, the domain name system is a system in which it's going to translate IP addresses into names or names into IP addresses. And so, how does that work? At the kind of global view, all domains have some top level, so a top level domain. So that could be .com or .edu or .org, and there is some bank of servers that is responsible for holding kind of where to go to translate some specific IP address, some number, into a name, and then those ship out to kind of other folks to figure out how those numbers are supposed to be translated. And then eventually you get to some authoritative answer. So the ISP that gave out the name is sitting down there somewhere. So when you register a domain name, at some level, you're registering it with the top level domain. Whoever's registering it with that top level domain um, might be responsible for kind of that DNS resolution, so that when somebody types google.com, it fetches the right address. This is a vector for attack. It is challenging, but if you are able to spoof a DNS address, you could send somebody to someplace other than google.com. Um, and so it is something that requires protection. DNS is a kind of messy distributed system, but it gets the job done through several different layers. So this is an example of a tree, and honestly, the trees aren't very deep most of the time. You have kind of your top level domain, which then points to your kind of whoever the DNS is going to be responsible, and then perhaps that pushes down to the specific servers that are saying like these are my subdomains. But it usually doesn't get too messy, which is why you don't usually see very many addresses that are things like um, the dot blanket dot is dot big. Like you don't usually see .com, right? You usually don't see very long dotted things here, because that tree is not necessarily very deep. It is very well distributed though. So when you do a DNS request, then what you're doing, like you're saying, hey, I want to look for google.com. You go to the root name server. That root name server usually says, hey, why don't you go to this other name server? Until eventually you get to the name server that's responsible for actually giving you the address. And then that name server then tells the person who asked for the DNS address exactly where they could have come from, right? So when I type google.com, all of this stuff could happen. Now, Google's pretty popular, and so you might say, why do we have to go through this long, crazy process, wasting all of this internet access when Google's very popular? And you'd be right. We don't have to do that. But this is kind of the general idea of how an address might need to get resolved, and how it jumps through these different steps. Um, More specifically, though, the actuality of what happens, and all of these pictures are on the wiki for DNS, and there are good pictures in your book too, and I'll link the book in the description down below. But in actuality, what really happens is that kind of locally, your OS is going to store a local cache of addresses that you recently visited or often visit, and that way that never has to actually go fetch the DNS unless it gets stale or old. And so locally, you'll store a cache. Sometimes your web browser might even have a mini cache to make things fast. Um, and even if you don't store it locally, your ISP might. So, if something's happening in Baltimore and everybody's hitting some Baltimore news source, then your ISP might save those in a local cache because most of the people that are coming from this area might be saying, "Hey, what's going on in Baltimore right now?" or something like that. Um, so these caches are helpful to kind of keep the DNS snappy and quick. Um, and they kind of just sit in different places. You got some next to your web browser, maybe some next to your DNS, maybe some next to your ISP. But no matter what, you eventually can go all the way out and get a full answer. And that leads me to two or three, I guess three total applications on a Linux box that I would like to point at and look to. Hold on, let me clear this. I guess clear. And these are three quick applications that have a lot of utility for me, and there are a lot of things that I use to debug DNS and other issues like that. One of them is called Nslookup, and Nslookup is pretty straightforward. You can do an Nslookup on some IP address, and it will tell you kind of what names it resolves into. So you can see 8888 is DNS Google. I could do an Nslookup on Google itself, and it will tell me um, what address that might be. Now, you might see that subsequent searches might hit slightly different addresses. That doesn't seem to be happening this time. But sometimes that's possible, and that's not a mistake. And we could talk about that another time to keep this video kind of tight. Um, you will notice that it gives this address, and then it also gives another address. This is the version 4 of the Internet Protocol, IPv4. And this is version 6. The version 6 addresses are much longer. Um, IPv4 kind of ran out of space a while ago, and we kind of hack our way through it. Again, this is not the video for that, to keep it short. Um, but Nslookup is a useful tool. So if you want to know, say, um, what IP address is being associated with Wikipedia when you go there, then you can do an Nslookup and figure that out. Or if you saw a random IP address in your web log and I don't know what this is, 40404040, no idea, I'll do an Nslookup of it. And the server can't find a 40404040. So let's try something else. Let's try 8.4.4.8. This is probably something owned by Google. Oh, can't find that one either. Wow. Well, we're missing a lot here. Well, I know what this one is. That one's also a DNS Google public DNS address. How about, oh, let's try this one. Man, lots of misses today. All right. Well, if you did see a random web logged address, you could look it up and see if it has a DNS entry to see if it's attached to a name. It might not be, right? Like the IP addresses don't have to be attached to an actual name. The name is for us as humans. It's not necessarily um, for machines themselves. So you can still communicate with an IP address. Let me pick one that is local to our region that probably has something on it. Let's see. Wow, I am striking out hard today. Let's see. So let's look up talkiefiber.com. You can see a couple addresses here. I wonder what this address is. Let's look up this 50.116.585 address. You can see this is newarklinode.com. It's DNS resolver. So again, like sometimes these IP addresses, I picked random ones here. They don't have names attached to them. They don't have addresses attached to them. This non-authoritative answer means it was grabbed from a cache and it didn't go all the way to Talkie to figure out what this IP address might be, and that's okay. So Nslookup is useful for that. Another one that's useful is something called dig, and dig can be useful to really like find a full path of some DNS resolution. Um, it gives you a lot more information. I don't use dig quite as much unless like there's trouble because you can do things like trace. And yeah, this is messy, but you can like trace what actually got hit in the process of trying to find this DNS resolution, and sometimes that can help you find like what paths are messing up and whatnot. Another command that I really like and then I'll leave y'all is traceroute. So this might be tracert in your system, or it might be a full traceroute in your system. And this isn't quite DNS, but sometimes it leans on DNS. And what it can do is trace your route through a network and tell you kind of which servers you're hitting. And sometimes that's useful to kind of see if the problem is, say, your home router, or if the problem exists somewhere else. And so in this case, I can trace route to that Google public DNS. What it's doing right now is trying to resolve domain names. So I was trying to turn that option off. There we go. And so you can see like this is my path from this server to 8888. And it just kind of makes its way there. Without the -n, it will resolve these addresses into names. So this is like linode.com. This is some router. It's possible that this particular address doesn't have a name, so this DNS resolution is pushing all the way to the end for, say, 2 or 3. One thing that's really, really interesting about these trace routes out of this box is that they're all taking different paths. And I think if you do this on like your home machine, if you have traceroute, I think you'll find that you'll probably follow a common path as opposed to breaking out in multiple different paths here. But since I'm sitting on kind of a shared network node, I'm getting different paths here. And I use traceroute all the time to debug my internet to kind of um, see if the paths are the same, to see what kind of these timings are. If you have big pings, like these are all 1 millisecond, right? So those are really small. But if you have something like, I don't know, 500 milliseconds, or if you get stars, those are hints that the network is having problems somewhere else. So I keep doing -d instead of -n. I do want to mention one more command, and that's the man command. So let's say you're trying to use dig, but you want to do something different, like change the port or something like that. If you type man space and then kind of the Linux command that you're looking for, it will bring up a man page, and you can read all about these options. Now, sometimes these are kind of meant for somebody who's already knowing what they're doing. You can find these on Google, so sometimes Linux servers don't even install the man pages. Man pages are on this particular server if you're in my class. But otherwise, you can go to Google and type man space dig and probably find the same thing. I can do it with you. Let's see what comes up. Yeah, so you can see it literally throws up the man page here. And it's the same stuff. And it might even be easier to see in this format. Okay, we're gonna kill the video here. So remember to take care of each other and take care of yourselves. See you guys next time.